Hey guys, Mr. Bowman here. Today's learning objective is in blue, and we are learning to use two-way tables to solve problems in relation to probability. So I've underlined that word or that phrase, two-way tables, because that's the gist of what we're going to be focusing on today. And just to help us support our learning, we've got an example of a two-way table, which we'll go through and explain its properties. And then linking with that example, we've got a whole bunch of questions where we're going to practice using the tables to answer certain questions. So the first thing we need to kind of develop or be aware of is a two-way table is basically exploring two variables. So if you have a look at the one here, we got boys and girls on this side, and we got left-handed and right-handed on this side. So if you think of what two questions you may have asked someone, that would kind of help you identify what variables you're trying to discuss or explore in your table. So what I reckon happened is this person would have asked the survey participants, what is your gender? And to which the respondents would have replied either boys or girls. And they also then would have followed up by that saying, what hand do you write with? Do you write with? And they would have responded with either their left hand or their right hand. So these categories aren't exhaustive, so people can write with both hands, and there are other genders as well, but we're just going to run with boys and girls, left-handed or right-handed, and we won't worry too much about those middle grounds between them as well. So hopefully you can see what that two-ways table is doing. It's asking one person two questions, and based on those two questions, you're responsible for within one of these categories here. So for example, I'm a male and I'm right-handed, so my response would have fallen under that category there. If you were maybe a female and left-handed, you would have fallen in that box there. So you don't fall in multiple boxes. Each person is only allowed to be in one of those four central boxes. And so what I like to call them central values. And then I'm going to change pen color for the next part. Once we've done that, there's actually a whole lot of extra information that happens. We then start totaling. So the ones over here, they are the totals of boys and girls. Boys and girls. And then down the bottom, we've got the totals of left-handed and right-handed people. And then the final one that we need to be aware of is we'll go back to blue for this one. The very total down at the bottom here, this is the total number of people involved in the survey or whatever it is. So we're going to call that the grand total. Grand total. And the grand total should be the sum of the males added together, and it should also be the sum of the left-handed and right-handed people together. Just to note, it is not all four added together. That will mean your grand total will be double by accident. So it's both of those added together. And just to recap, the sum of the boys would have been that 35. The sum of the girls would have been the number that we placed there. The sum of the left-handed people, they would have been 29. And the sum of the right-handed people would have been that blank space there. So we've gone into a lot of detail about the two-way table, so hopefully that's given you enough information to write out some notes about it. What we're going to do is I'm going to change pen colors, we're going to switch to purple, and we're actually going to get into the questions. So hopefully you can see the purple clearly. Okay, so first box here that I'm looking at, I know that this number plus this number should equal 35. So if I go 35 minus 17, that gets me to 18 right-handed people. And I know the total down the bottom of right-handed people, that's the sum of the two above, so that's 18 plus 23. That gets us to 41. And we can just double check these two numbers, 29 and 41, they do add to 70, so 29 plus 41, they add to 70, awesome. We could probably work out the girl total by doing 70 minus the number of boys, so that's 35. So there's an equal amount of boys and girls involved in this. And finally, we've got one box left. We can do it by checking out the left-handed people. We can also do it by going the other way around, checking out the males as well. So let's do the male or the female one. So let's do 35 minus 23. That gets us to 12. And for the final number, I normally just check that those make sense, and 17 plus 12 does equal 29. So we've completed our table. Hopefully you can see how everything works together and everything's integrated. We're now going to move on to how do we use this table to actually answer problems in relation to probability. And before we start, yes, we are going to continue to use our probability is always equal to F over T approach. This works for most probability related questions. Doesn't matter if you're looking at a table, a tree, or a Venn diagram, it'll still work. So, and we've got three categories here. We're going to do some basic probability questions. Then we're going to move on to something called conditional probability or conditional events. And then we're going to do some OR events to wrap it up at the end. So first question, what is the probability that a randomly selected participant is left-handed? So a random participant, that could be anyone here. So that could be all 70 of these people. So let's go probability of left. That's equal to F over T, which is going to be equal to 70 as our total. And how many of these people are left-handed? We're going to look at the left-handed total. So we're going to find left-handed and we're going to go down to the total. So that gets us to 29. So 29 divided by 70 will give us the probability of a randomly selected participant being left-handed, and that gets us to 0.4143. And again, with all probability questions, we're going to try to round to 4dp if we need to get involved in rounding. The next question, what is the probability that a random participant is a girl? So again, who of these people could be a random participant? Well, every person would be a random participant of that survey. So we're going to do the same thing. So that means our total will be that. So probability of a girl, that's going to be equal to F over T, which is going to be 70 total. Of those, how many of them are girls? Well, we've got that 35 girl total. So 35, and then 35 divided by 70, that's exactly 0.5. So those were the easier questions. I think a lot of us will be able to get those pretty quick. Let's have a look at the conditional ones. And I'm just trying to show us how the wording differs as well. So what is the probability that a random boy, so I'm underlining random boy, and we're going to compare that with above. So before, the other two questions, they said random participants, which could be any single person on that table. But this time around, it said a random boy. So we only care about the boys in this table. So that means we're just going to circle that boy row there. So we only care about those 35 boys. So let's get into that. So what's the probability that a random boy is right-handed? So it's going to be conditional. So what's the probability of being right-handed given they are a boy? So that's going to be F over T again. Our total, we only care about the 35 boys. Of the boys, 18 of them are right-handed. And we go 18 divided by 35, 0.5143. And again, that was rounded to 4 decimal points. So hopefully that made sense. We're not looking at all participants, we're just looking at the boys. And in question 4, what is the probability that a left-handed participant is a girl? So again, left-handed participant, we're not looking at all of the participants. We've only been asked to focus on the left-handed ones. So let's write our notation. So we're interested in, well, what's the probability that they're a girl given they are left-handed? Same deal, F over T. How many left-handed people there are? So there's 29 left-handed people. Of those 29, how many are girls? Those 12. So 12 divided by 29, that there is 0.4138, and that there was rounded to 4 decimal points. So hopefully we can kind of distinguish between regular or basic probability events and conditional events. And the final question we're going to look at is the OR type event, what is the probability that a random participant is a boy or right-handed? So random participant, so we do care about all of the participants, and we're interested in, well, who is a boy or right-handed? So we'll finish up our question down here. So what is the probability of a boy or right-handed? That's going to be equal to F over T. So we've already said we're interested in all participants, so that means our denominator is going to be 70, and we're now going to think about the numerator, so who meets this criteria. And this is where the central values come into play. So we need to look at the 4 central values and which of them would be boy or a right-handed person. So let's have a look at this first box here. 17, would they be a boy or a right-handed? Yes. So they've met the boy criteria, so they get a tick. 18, would they be a boy or a right-handed? Yes. They actually meet both criteria, so they definitely get a big tick. Girls who are left-handed, they are actually a no. So we're going to cross them out because they don't meet either of the criteria. And then finally, girls who are right-handed, that's a tick as well. So that means all of those central values that we ticked are the ones that are going to be in the numerator. So we're going to go 17 plus 18 plus 23. So when we add that all up, so 17 plus 18 plus 23, that comes to 58. So 58 divided by 70, and then when we do that, that gets us to 0.8286, and again for DP rounding. So before we finish up the video, I just want to emphasize a common mistake that people are going to do for this question here. So a lot of people are going to say F over T, 70, and a lot of people are going to add up the boy total, which would have been 35, and we're going to add up the right-handed people, which would have been 41. And then they would have said, well, the probability of that would have been 76 over 70, and then 76 over 70, they'll then go ahead and tell me that the probability is 1.0857. And there's a few things wrong with that. A probability can't be more than 1. So that's a bit of a deal breaker. But what's happened by using the 41 and the 35 total, you've actually double counted the 18 that met both of the criteria. So that 18 was counted as part of the right-handed total of 41, and it was counted as part of the right-handed or the boy total for that 35. Hence why we've double counted, and we can't do that. So when you're looking at these OR events, make sure you focus on the central 4 numbers. Do not use the totals for the numerator around the edges. So just to confirm, that was very wrong. So I know it was a relatively long video, but hopefully this video explained heaps about two-way tables. If you haven't already, make sure you get your notes down, make sure you get the examples down. Now let's get into heaps of practice.